It is Wednesday, my dudes. I'm not doing that other thing. Okay, so welcome to 5.1.2. Happy Wednesday, everybody. So I mentioned yesterday that when it comes to trigonometry and sine, cosine, and tangent, the hardest part is not necessarily using them, but figuring out which one to use and how to set it up. Once you've got these set up, it's pretty much just solving for x, a process that you learned last semester, and it should be very familiar for you. I don't want to say simple, but familiar at least. So today the key is going to be just practicing this and, practicing SOHCAHTOA and remembering which one to use when so that we can get really familiar with that. Speaking of SOHCAHTOA again, here it is just to remind you of what it looks like, what it does, what it reminds us of. So we go over this again. S-O-H tells us sine equals opposite over hypotenuse. C-A-H tells us cosine equals adjacent over hypotenuse. And TOA, T-O-H, tells us that tangent equals opposite over adjacent. So if you want to write this down somewhere, have it available for you, just so you can remind yourself of what this is and what order these should go in, is going to be a huge help for you today. And of course, it's not cheating to write this on the top of your test or something. Just remember the order and how we're going to use this, because this is going to be really important for us today as we go through and practice these problems. So this is the majority of what we're going to be working on today, is just this choosing a trig tool problems, solving these. You've got several, I think 6 more after this, other than A, B, and C. I'm going to run through A, B, and C with you, actually. I'm going to do these so I can show you the process, how I do them, so you can see what it looks like. And then I'll give you 6 more after that so that you can practice them. The answers to all of these are at the very end of the slideshow on the last slide, so if you want to just skip ahead to those and take a look at the answers to check your work as you go, feel free to do that. But it also says, look through to see if there's any familiar ones. Like for B, we do know the slope of 45 degrees. We should know this one, but when I go through it, I'm still going to do it kind of the long way, showing you the steps with tangent, just to make sure we're all clear on those. But if you know a shortcut for any of these, feel free to go ahead and use it. So I'm going to show you how to do the work for A, B, and C, and walk you through it. This is A, and you can see that I've put the diagram up there, and I've also labeled the three sides, O, H, and A, to show us which one is which. So if we look, X is O for opposite, because it's across from that 28 degrees. Again, it's on the opposite side of the triangle from 28 degrees. If 28 degrees was a flashlight and it was shining on something, X would be the thing that it would be shining on, where the light would actually be hitting, as opposed to A and H. That unmarked side on the bottom is A. It's the adjacent side. It's the one that's touching 28 degrees and isn't the hypotenuse. And then 19 is our hypotenuse, the one across from 90 degrees. So if I write out SOHCAHTOA over here, like I've got on the right, the two sides I care about, X and 19, are my O and my H. Those are the two that I've underlined there. So that means if we look at SOHCAHTOA, well, I only see O and H together in SO, S-O-H. So that means I'm using sine. That's how SOHCAHTOA tells us which one we're going to be using, sine, cosine, or tangent. So in this case, we should be using sine. So if you go down to a little bit below the triangle, you can see I've got sine of 28 degrees equals x over 19. And I got that because if we look up at the top, I've got x is O, 19 is H, and if we look at SOHCAHTOA, it's S-O-H, which tells us that sine is equal to opposite over hypotenuse. So the opposite side, x over 19. Now from there, that's my setup. That's what I'm starting with. It's basically just an equation. I'm just solving for x. Sine of 28 degrees may look really intimidating, but if you put that in your calculator, you just get a number. It's exactly the same thing as if this were something like 38 equals x over 19. It's just a number. We know what to do for that. We're just trying to get x by itself. That's all we're trying to do. So when you see that sine or cosine or tangent of a number, don't get freaked out. Don't panic. Don't think it's something weird and intimidating. It's just a number. Treat it like you would anything else and just solve for x. So for this one, all I've got to do is multiply both sides by 19 to get x by itself, to get rid of that 19 in the denominator. So I get x equals 19 times the sine of 28. If I put that in my calculator, I get x equals 8.92. Now, on a test or something, I would actually accept either of these bottom two lines as your answer. X does equal 8.92, but it does also equal 19 times the sine of 28. In this way, if you don't have a scientific calculator, you can go ahead and just leave this as your final answer. This is known as an exact answer. Perfectly acceptable. So either of these answers is acceptable for A, 19 times the sine of 28, or 8.92. Now we're going to do B in the exact same way. Notice again, this is 45 degrees. We could figure out x based on what we just remember about the slope of 45 degrees and everything, but if you don't, we're just going to fall back on tangent. So, again, I'm going to start by labeling all three sides. Now, this is it's oriented a little bit differently. It's turned a different way. It's rotated. It's not in the exact format of a slope triangle. But remember, opposite, adjacent, and hypotenuse are not dependent on location based on where it's facing. It's just connected to where the angle is. So 8 is our opposite. It's across from 45 degrees. Again, if 45 degrees is that flashlight, 8 is what would be illuminated by its light. So 8 is opposite. X is adjacent. X is the side adjacent to it, right next to it, and is not the hypotenuse. And then H, that missing side, is our hypotenuse. So we have something written for 8 and X. We only care about 8 and X, so that's our O and our A. Going over to SOHCAHTOA, we can see that O and A are only present in TOA, T-O-A. So with T, we're using tangent. Going down to the bottom then, we've got tangent of 45 degrees equals X, or 8 over X. Now this is the one where it gets a little more complicated, and it's a little unfamiliar. You might think, oh, we just divide both sides by 8. But no, because that would give you tangent of 45 divided by 8 equals 1 over X. That wouldn't give you X by itself. We have this problem where X is not only not by itself, it's also in the denominator. We've got to fix two of those things. So we can't get X by itself in one step here. This is a two-step process. So we're going to do, first, to get X out of the denominator, multiply both sides by X, which seems a little counterintuitive. We normally don't move X around, but we want to get it out of the denominator so that we're not solving for a fraction. So we get X out of the denominator by multiplying both sides by X, and we get X times the tangent of 45 equals 8. That's not our final answer, but we're closer. X is out of the denominator, but it's still not by itself. Well, we just now got to get X by itself. X is being multiplied times the tangent of 45, which, remember, tangent of 45 is just a number. So we divide both sides by the tangent of 45, and then we get X is equal to 8 divided by the tangent of 45, which, turns out, is just 8, because the tangent of 45, the slope of 45 degrees, as we remember, is just 1. But if you don't remember that shortcut, you can go through these steps, and it'll still get you the right answer. And the last one to walk you through here is C. So looking at this, labeling all three sides, 61 is in the top corner, so the bottom side here is our opposite. The unlabeled one is opposite, and it may look weird. You might think, oh, but 18 is my change in a Y, so why isn't that my opposite? Well, it's because the angle we care about is 61 degrees, not that bottom right corner. So we're going from the perspective of 61. It's always based on the angle you have, not just based on how the triangle looks. So we look from the perspective of 61 and see what's across from that angle, and the blank side is our opposite. X, of course, is our hypotenuse, because that's always the same. It's across from the 90-degree angle. And then 18 is our adjacent, because it's the one that's touching 61 degrees. So we've got A and H. Looking at SOHCAHTOA, we've got the only one that has A and H together is C, Ka for cosine. So we're using cosine in this one, so our setup is cosine of 61 equals 18 over X. Very similar to the last one we just did, where we need to get that X out of the denominator and by itself. So we multiply both sides by X to get X times the cosine of 61 equals 18. Then we divide both sides by the cosine of 61. We get X equals 18 divided by the cosine of 61, which is about 37.13. All right. That's how you do these. There's 6 more of them. Again, the answers are at the very end. Draw the diagram if you need to on a piece of paper. Actually really helps to draw out that diagram. Label everything. And then write in the O, A, and H. Label them, because that's the place where everyone gets... That's the biggest place for mistakes, is mislabeling the sides. Once you can label those, figure out which one you're using, sine, cosine, and tangent. It's a lot easier to figure out, because you know which two sides you have. Do you have the opposite and hypotenuse, the adjacent and the hypotenuse, or the opposite and adjacent? Once you know which two you have, you can pick which one you're using, sine, cosine, or tangent, set it up, and then just solve for X. And it's going to go one of two ways. Either like the first one did, A, where X is in the numerator, and we just multiply both sides by the denominator, or if X is in the denominator, like this one, and we need to multiply both sides by X, and then divide by the sine, cosine, or tangent of our angle. So I'll let you go ahead and work on those, see how well you do. If you have any questions, again, jump in the Google Meet, email me, whatever you need to do. I want to make sure you understand this. And then I will see you again in the ending video. So see you in a minute.